Okay, so obviously in the circle we drew, we had it so that this circle here had the center on the outside. We could have also had the center on the inside. So for the formula to be proper, I think we need an absolute value sign. Okay, so it's not too much of a leap of faith though. So there is an interesting thing. So if you have a circle, you have another circle, and you have a cyclic quad. Cyclic quad. Alright, does this work? Do something about it. So somehow we need a cyclic quad. Okay. And the angle bisectors have to meet. Yeah, so the point is you have a cyclic quad and the inside angle, the inside circle is the incircle of the quad. If that's true, and say C is the distance between the centers. Is it true that so B is the radius of the bigger circle? B minus C squared plus 1 on A plus C, B plus C squared is equal to 1 on B squared, 1 on A squared. So maybe someone can show me the proof of this at some point. Let's assume that for now, okay? Okay, how do we re-express this? So assume this, express this maybe without reciprocals, maybe as, how would you do it? So maybe if we just collect the denominators, for example, 1 on A squared equals B plus C squared plus B minus C squared. this gives you that. So you get b squared plus c squared times 2 times 2 a squared equals b squared minus c squared all squared. Does not, at the moment, doesn't look helpful. Maybe it is though. Okay, if we square root this, hmm. How do I get a plus squared plus b squared minus c squared? Is it possible to show this is equal to a root 4b squared plus a squared? Is that possible to show? It's kind of a squared 4b squared plus a squared. We have a squared plus b squared minus c squared all squared. Somehow I completed that square. It's kind of crazy. You complete that square. Oh, so you add an a squared, a to the fourth, then you subtract okay, so you add, so you want to complete the square here, so you want to add a4 plus b squared minus c squared squared, and you want to add this plus 2a squared b squared minus c squared. Yeah, that's how you complete that square. And if you do that, so you got the 2a squared already, see? Oh, okay. You got the 2a squared, but then you get 2b squared and the c squared cancels out. Oh. But then you're adding a half a squared there. Yeah, that's right. So then complete the square, you get a squared plus b squared minus c squared all squared equals a squared outside of 4b squared plus a squared. Oh my gosh, screw you. Okay. Alright, so then we're in business. So now we have this. Yeah. Oh, what's better, the absolute value? Okay. Okay. Let's do this. Okay, well, there's no 2 there. Yeah. But now let's divide it by 2. So a squared plus b squared. So divided by 2, yeah. Get rid of the square there. Let's make that a square root. Get rid of that square divided by 2ab. And 2ab. So remember, this is the cosh of the inversive distance, okay? And this other thing, the a's cancel. You get the square root of 1 plus a on 2b squared. Okay. So if you square it, you get cosh delta squared equals 1 plus a on 2b squared. Okay. And then you have cosh delta squared. Okay, so cosh delta squared minus 1. So remember this cosh delta squared minus sine delta squared equals 1. So this is because it's e to the delta plus e to the minus delta on 2 squared minus e to the delta minus e to the minus delta on 2 squared, right? That's equal to, so it's all over 4. And can you see that the e to the deltas cancel, and you just get the cross term, which is 4, right? So it's 1. So that means cosh squared delta minus 1 is equal to sine squared delta. Okay. So this is the punchline, I guess. The punchline is I have a huge headache, and that sine squared delta equals a on 2b squared, and sine of delta is equal to a on 2b. Isn't that crazy? So the condition for a cyclic quad to have an inner circle is that the sine of the inversive distance be the smaller radius over twice the larger radius. It's a very simple expression, whereas this was the original expression. Okay, so we might still want to figure out why that original expression is true. I guess that goes under the applications section if you want to see the application of inversive distance.